Hey everyone, moving on to the new chapter, everyone's favorite chapter, quote unquote favorite, vectors. And well, I'm well aware that in EMath it is two dimension, x and y coordinates only, whereas in H2 math it's x, y, z coordinates, the three dimension coordinates. For the most part, I'll be doing the three-dimensional coordinates first, the x, y, z coordinates first, but don't worry, I will also be making additional videos specifically for two dimension as well. Alright, so let's start with the introduction on what vectors is. So maybe I'll start with the two dimension ones, and that will provide a easier illustration. So let's say we have the Cartesian axis, y, x, and then the origin. Let's say I have a point and we label this point as point A and has coordinates 1, 1. And on the other hand, we have coordinates B. Let's say we have coordinates 3, 4. What vectors is all about is simply the movement from a point to the other, right? From a point to another. And it's not just any movement, it's the shortest movement from one point to the other. And what do you mean by shortest? Straight line. So instead of going from A to B like in this direction, you are just going to connect one straight line from A to B. And this is how vectors is all about, right? It's just the shortest distance from one point to the other, and then working it from there, or expanding it from there. So clearly, when you're talking about movements from one point to the other, there is a direction involved as well. And as you can see, I've already included the direction by putting the arrow down there. And basically, it means that you're moving from A to B. And if you notice, how do we actually calculate this particular vector? This particular line connecting A to B is the change in the coordinates, right? So in A, it is 1, 1. In B is 3, 4. And simply, you just need to compare the change in the x coordinates as well as the y coordinates. So 1 to 3, the coordinates change is 2. 1 to 4, the coordinates change is 3. And you realize here that when you look at, or when we want to represent vectors, it's about the movement and it's no longer about the coordinates, right? There's no such thing as coordinates of a vector. Instead, vectors are represented with the vertical matrix, or rather the column matrix 2, 3, or in a more generic term, A, B. Alright, so this is just two-dimensional. Of course, if we talk about three-dimensional, it'll be A, B, C, or X, Y, Z. Alright, of course, this is the X, Y. Alright, the first row being X, the next row being Y, and then followed by Z. So this is really what vectors is all about. Basically, how you're gonna move from one point to the other, and what is the movement involved, and that particular movement is the vector. So there are many ways to denote a particular vector. So let's say we want the vector AB, alright? So how we write it is AB, and then we draw an arrow on top, right? So this arrow on top is signifying where we are moving from A to B. Alright, so AB, and then with the arrow on top, from A to B. And we know that this is basically 2, 3. Alright, 1 becomes 3, so it's plus 2, 1 to 4 is plus 3. On the contrary, if we were to move from B to A instead, you notice that it's actually the same idea, just that we are now moving backwards in a sense. Alright, so this is from B to A. And of course, 3 to 1 is minus 2, 4 to 1 is minus 3. So all these are just simple notations, alright? Now, what other notations are there? Okay, so that is the very basic form. Another way to denote vectors is instead of, using the arrows on top, alright? So let's say we use the same points again. So A being having coordinates 1, 1, and B having coordinates 3, 4. And we have the origin, okay? So another way to represent vectors is what we call by the position vectors. So position vectors, basically the name, or the clues in the name, position. So you're always taking reference to the common point, most of the time, actually in fact all the time, the origin. All right, so position vectors, the definition is very simple. The vector going from origin to any point, right? So let me, any point, let's just say at the point x, all right? So point A, B, or whatsoever. So OA, we know that it's gonna be, well, 1, 1, all right? Another way to represent this, if they were to define it for you, is A with the tilt at the bottom. Now, this A tilt at the bottom, sometimes you see it printed, is actually bolded, all right? I can't write bolded, so bolded A, small letter A. So that is how you were to represent, right? So sometimes you'll see bolded A, it is simply, you can represent it using this way, right? So this means the vector A. Likewise, we can denote OB, the position vector OB, as B. So position vector, very simple vector going starting from the point O to wherever point that you want to end up with. All right, so that is vectors. All right, basically the shortest distance from one point to the other, and I'll continue with more features of vectors in the next part.